you are surrounded by help. You got me in the office you can come see. You got tutors. You got videos online. You got my videos online. If you're like, I didn't even want to listen to this guy in the first place, don't watch my videos. Watch somebody else's videos. It's fantastic. All I care about is you get the idea behind what we're doing. That's the most important thing. And if you understand something else, that's fantastic. I mean, I'm not going to say I'm the greatest, I'm the best source of information. I am just here to communicate stuff, and if I'm not doing it well enough for you, then you find somewhere else that is. Or you come talk to me and let me know what's going on. I feel bad for some of you guys because I don't think you're coming in with the right amount of skills. And that's going to be really difficult to get through calculus if you have a lot of issues with algebra skills. That's a lot to kind of overcome all at the same time. So you have to self-evaluate. You should be at a level where you can self-evaluate and say, man, I really don't know what I'm supposed to know. I need to get some help. Maybe I should go see Jeff and get some suggestions on what to do. Should be good students to get to calculus. All right, that's enough ranting. So it's wide open. Anything you want to talk about. We can talk about y is 2 minus 5 negative. I mean, any level. I don't give a shit. Anything that you want to discuss. We can talk about practice test problems. We can talk about homework problems. You can talk about problems from the quizzes. It is wide open. And if you guys don't want to talk about anything, it's going to be a very short class. Because that's all I have planned. I have nothing planned. Nothing new. I've given you guys enough information, I think. And I think you agree with me. So whatever you want to talk about.
Do you want to just go over the practice test?
We could do that. If that's, if nobody else.
Just to know, Tuesday is through what chapter?
Oh, yeah. So it's through section, we didn't make it to section 2, I think it's 2.8. Let me make sure. Yeah, we didn't make it officially into 2.8.
So what did you say?
Which kind of sucks, but we'll work with it. Through 2.7 is due. Homework is due on Tuesday. Monday's a holiday, so take advantage. So if you want to, so if you guys are sitting there and nobody's asking questions that you care about, you could try the practice test out if you haven't tried that out. I think everybody has a copy of that, right? I do have the answer key that I will not give to you yet because I desperately try to trick you into doing what's best for yourself.
Okay, so I got literally the very first homework, chapter 1 review back, and you said to correct it.
Yes.
Which I had a lot of trouble with because I needed a little review.
Sure, of course.
But I went into the math lab and I did the homework with the math lab.
Okay.
And you're still telling me to correct it.
All right. So let me see if you guys can understand this. You ready? The purpose of the math lab is not to make sure all your answers are right. Do you understand that?
Well, that's not what I was in there for.
I know. So you're still going to get some stuff wrong because they're not going to sit down and show you every step for every problem. They're going to explain an idea, and then you might go with it and do something wrong after they explain some idea. You can make some little mistakes.
Okay.
Great. So you're not going to get it would be bad if everybody went to the center and got a perfect paper from it. That would make me suspicious.
Right.
So I don't think you made like a crazy amount of mistakes, and some of it might have just been not enough work shown. I can't remember. A lot of what I did with the homework was there just wasn't enough work shown, or the graphs were just no scale at all. I mean, we talked about that. Right? That's
Well, in terms of asking questions for today, having an open floor, I mean, there's so many for each chapter that it's kind of hard to know where to begin. Do you know what I mean? Like,
just pick somewhere. Maybe start at the beginning. I don't know. It's up to you. You can start wherever you want to. You can ask whatever question to get things going. If nobody else is asking anything, it's your floor. You can ask whatever. If nobody's saying anything, so you can ask, and they'll love you for it because they all have the same questions.
2.7.
Okay.
I was doing homework on that last night, and number 2 online. So I don't know how it relates to in the book.
Sure.
is to find an equation of the tangent line to the curve at the given point, and it has the equation and the given point. And I went through it like 6 different ways and just don't know, I don't feel like I got the right answer.
So exactly what do they
So
give?
it's y equals x cubed minus 3x plus 2 with the given points 3, 320. So
Okay.
find the equation of the tangent line to the curve at the given point.
Okay. So I'm going to do a problem like that.
Okay.
All right. Okay. First question for you, for everybody, is how do I find the slope of a function at a point? Slope of f of x at a f of x. This is how calculus works. You have an idea. Every problem could give you a setup that's different, but they all could use the exact same idea. So this idea by itself, what do?
You find the slope first.
How?
You do.
You have
Well,
two different kind of ways you could do it.
This one was asking for you to do it the way with the f, a plus h minus f of a. Over h.
Yeah.
In case you forgot.
Yeah, I don't know. I just learned everything I need for just that day. All right. Yeah, there you go. That's one way. What's the alternate way you can do this? The one we just kind of talked about last time is to let x go to a.
I'm trying to that way too.
No, that's just an alternate thing. If they told you to use this way, you better use this way.
Well, I assumed it was that way just based
Oh.
on the question. And I tried it both ways and I just
All right.
wasn't getting to the
So I'll
answer.
tell you this. Let's see if this kind of makes sense. The larger the power gets in your function, the less I would want to use this one probably, because then I'd have to, like if I had a x to the 5th power or something, I'd have to raise a plus h to the 5th power.
Mm-hmm.
You know, I showed you the Pascal's triangle thing, but still it'd be kind of disgusting, right?
Mm-hmm.
So let's see. Let's give us, here's a specific example. So let's say f of x is 7 minus x plus x cubed. Just to be different. And I want to know, let's start off with just the slope at the point. What you got, Jeff? I don't know, Jeff. Let's say -1, sure. 7, I think that makes sense. Yeah. Now, is everybody cool with the question so far? Is everybody cool with that? That's playing along with me right now. Okay. They could have said, find the slope of this function at the point x at where x equals -1. And then I would have had to plug -1 in to get the y piece, of course, right? So there are these little different ways that can give me information. I just have to know what it is I need and how to get it. Here they just gave it to me. Thank you, problem. Right? So now I can do this. I get everything I need to be able to do this. The limit as x goes to, where am I going towards?
That was the other question I had, because I wasn't sure sometimes when the h goes to 0.
Sure.
Is it always h goes to 0?
Yes, because then the a is right there.
Okay.
It's built in. See, the main difference between these two, I know a is here too, but here the a is more built in, and this is dealing with h. Here, this is where the a really is.
Okay.
Yeah. All
So
right.
it's -1.
Yes, because I'm interested in the point where x is -1, so I'm going to let it go towards -1. And then I just fill in what's up here. And of course, what is the main idea behind that piece by itself?
Slope.
Slope, y2 minus y1. Never lose sight of what we're building on that we know from before, right? That's just slope, y2 minus y1 over x2 minus x1. It's beautiful. And we built on this extra business for when I don't have a straight line. I got this idea of limit to help me. Okay, all right, let me stop right there. Everybody looks like they have a question, but nobody's saying anything, but I'm just going to keep going. You guys all right? Okay. guys are averting your eyes. That's all right. So then I got f of x. So that's the f of x right there. Minus, what's f of a?
Well, that was the other question I had. So
Wait, tell me.
In some examples in the book, a was a, in this case, -1. But in other ways, I can't remember if it was in the book or on the homework or whatever, f of a was actually the entire equation. So a would be the f of x equation with a put into it.
That's what f of a always is. I mean, what does f of a mean? That means take a
Right.
and put it.
For me, when I see the -1 in there, I think f of a is -1.
No,
Right?
no,
Okay.
no.
So it's the whole equation with -1 plugged in.
Definitely.
Okay,
Yes, yes.
That's
All
what
right.
I was getting confused.
What is a? -1. You knew that right here when you told me this.
Mhm.
So f of a, that means take whatever a is and plug it into f. Now where is that up here? It's already done for me. What's f of a? What's f of -1? I heard it. I think I heard it. 7. Right? How the shit do we know that? Because there, look, what the hell's a point? A point is when x is this, the output is this. All right, they gave me the point. If they would have said at x equal to -1, what would I have done? I would have plugged the damn thing in to figure out what the output is, to figure out what the y value is. That's what I mean. Where calculus doesn't change everything, calculus builds. Algebra can't change. It is true, period. I can't change algebra, but I can do more with it than we could back in algebra class. That's the basic idea of calculus. So don't let go of the shit you know already, hopefully. So 7, that's the output. So that's what f of a is. So there's f of x, there's f of a. All over x minus a. So x minus -1. So x plus 1.
Okay.
Yeah.
Example 4 in the book. Look at example 4 in the book. And tell me what I'm doing wrong and how I'm thinking about it wrong.
Oh yeah, they just left an a in. They didn't specify a number for a.
Okay.
Yeah, that's all.
Okay.
That's all example 4 is. Yeah. And that's actually what the whole point of 2.8 is instead of putting an actual number in here, let me leave a letter here so I end up with the function. So what if I would have had this whole question again, but I wanted to be at the point where x is 2? I would have had to do all this work again. Whereas if I just make this a, I can get the result for any value of a. And then I just plug the a into that result. I don't have to do this whole process every time.
Okay.
That's the idea with example 4.
It gets confusing as a new to calculus individual to just decipher what everything means when you're being thrown all the different stuff.
But
So-
the idea of not plugging in values for variables is an old idea. It's an algebraic idea, right? The thing where students say, oh crap, there's no numbers in this equation. Well, it's still the same idea. You still solve the same way you always do.
Mm-hmm.
That's all that is. It's just, what if I didn't tell you what a was? How far could you get anyway?
Mm-hmm.
Right? And then I tell you what a is, and I can just plug it in at the end instead of having to do the whole thing every time for a different a. I just do it once with a. That's the idea, right? So why, all right. Let me see. So what do I do there? What do you get on the top?
Combine
Yeah,
terms.
what do you get on top?
X cubed minus x plus 1.
Okay, and now what do you do?
Plug in the 1.
Plug in the 1, 11, the -1.
Negative 1.
And what do you get? You get -1 plus 1 over -1 plus 1. You get 0 over 0. You get indeterminate. So what does that tell me I have to do? You don't just write indeterminate and move on, like some people did in the homework. What does indeterminate mean? Why does that kind of suck for us? Because we're so not done. It means do something so you can determine the answer,
Do you
right?
take the 0 and now plug it into this point slope?
What zero? What? No.
Well, 'cause
No.
zero-
What do I do to evaluate this limit
Mhm.
that I know that it's indeterminate and there are polynomials in there? What do? We know what the process is. If there were radicals in there, I would use a conjugate, right? But there's polynomials, so what do? There's polynomials, so what do? Factor. Yes, we've done that a lot, right? I want to try to kill the problem. You can see the problem on the bottom real easy. But there's an x plus 1 in here, believe it or not. So how do you factor the top?
X minus 1. Or x squared minus 1.
Yeah, x squared minus 1. And of course, x squared minus 1 is?
X minus 1, x plus 1.
Yeah. Problem gone, right? I love that idea of how you can just concretely see. I can't do the limit. There's a problem. Let's kill the problem, then we can do the limit. I personally love that shit. You can see the problem dying. That should feel good on one level. That's making it not, okay, die, right? And again, what's the one place I'm not allowed to do this? When x is -1. But we never get to -1, so I'm allowed to do it. Yay! It should feel good, maybe. I don't know. Limits are a little bit freaky, but they allow us to do so much because we never get to the problem spot. So now if you just evaluate this, when you plug a -1 in, what do you get?
-2, or positive 2.
Yeah, -1 times -2, so positive 2. What the hell does that mean? Coming back to the problem. What is that? What is 2?
That's your slope.
That's your slope. I love it. And then, so that would be like part A maybe for a problem I would give you. Part B would say, to be honest, I wouldn't give you no part A. I would just say this. Find the equation of the line. The tangent line. At that point. Right? Do you have everything you need now? Yeah. You got x1, you got y1, you got m. Right? Then you can throw it together. So that's exactly how you do.
I did it that way literally 6 times, trying different things, and I kept getting it wrong, so I guess I'll talk to you after.
Okay, yeah, that's the thing. Okay. Is that cool? I mean, this I don't mind spending a lot of time on because this is a huge, important idea. You're going to see this question a lot. Every time we learn a new way to take the derivative of something, which is the slope, they're going to ask me this question related to that. Right? We'll do trig functions derivatives. Now you're going to say, find the equation of the line that's tangent to the equation y equals tangent of x minus 7. Every time we learn a new derivative, that question is going to show up. So this question is basically going to be on every test. And on one level, it's just algebra. Okay, maybe. Let's finish this up. So what I know m is 2, check. I know the point is -1, 7, check. And now I can just throw it into my line form and get my equation. All right, so then you end up with y equals 2x plus 2 plus 7, so 2x plus 9. Coolness. So what does that do?
That's the equation of the tangent line.
So what does that do relative to this guy? This hits this at this point with the same slope this would have. That's what this guy does. So the tangent line is a line that has the same slope as the function at some point. That's what the tangent line is.
So it gives you the point where that tangent line crosses the curve. That
Meets the curve, yeah.
Right.
So this
meets the curve.
line meets this curve at this point, moving in the same direction this would at that point. I like it. So if I have a curve like this, tangent line would be maybe like this. Oh crap, I need to do that. Meets it right at that point, going the same direction as would be going right from that point, if it was allowed to just keep going. I like it. So my favorite thing is twirling something in a circle. And if I let it go right here and it's moving in this direction, it's going to go, wee-ha! That would be the tangent line at that point. Whoa, right? Throw it at somebody, goes around the legs, they fall over. Xena wins. Okay. All right. I love it. Do you want to do another one of these, or do you want to do something else? Completely up to you guys.
I have a million questions.
Sure,
but
go ahead.
I don't want to monopolize.
It doesn't seem like anybody else is vying for it, so you will be their spokesperson.
Seriously.
They all love you. Yes. They're afraid to ask questions or something.
Because you make us feel a little bit stupid, to be honest with you. I mean, it's like whenever I ask a question, you act like I should already know it. And the way that the education system is in our country today, it's all about test scores. It's not about mastery. So we're all getting here with gaps in our knowledge.
Okay. True. This is true. I'm not going to change my standards for my class, though. I can't.
No, I don't want you to.
And as a teacher, it's a very frustrating thing. I can't take up time teaching pre-calculus material in calculus more than I already have, because I got a lot of stuff to get through with calculus.
I get it.
So as a student, you have to speak up about, like, your pre-calculus teacher. Really evaluate.
I took pre-calc in 6 weeks over the summer, so.
Okay. So maybe that was not the best idea. I don't know.
Time, you gotta get through. But anyways, regardless, so I do have more questions.
Okay, but real quick word about it. All right. I love you guys. I get a really bad feeling about this class right now. It feels kind of like the wrong vibe in here. And I'm all about helping people get through material. I can't teach pre-calculus. I can't in this class. I'm not saying I can't teach it. I teach it when I'm teaching pre-calculus. If you come to my office hours, or like today, you can ask any question. I'm going to treat a calculus student differently than I would a pre-calculus student when they ask a pre-calculus level question. I just will. And that's one thing about like tutoring. This is one reason why we wanted to have a separate tutoring center for developmental math and higher level math, because somebody might come in and sit next to a calc student and they're in Math 90, and the calc student asks a factoring question, and I'm like, come on, you should know that. And the Math 90 student like, oh, I'm not going to ask him anything. But I didn't treat that calculus student incorrectly. They need to know that that's something they should know. But poor Math 90 student says, oh, he's mean. No, it's the level you're at and what you should be expected to know. Now, why you don't know that could be unfair, because your teacher didn't teach you or whatever. But you need to know you're supposed to know it. So then you go back and you do what you got to do after that. Does that make sense?
Of course.
I mean, all right. So, okay. I think somebody wanted to do one more of these. Is that true? Do you want to do one more of these, or yes? All right, let's do one more of these. And then we'll go from there.
So is a general rule you only use the a plus h version of the formula if it's a low exponent versus...
I mean, it's not a
Because
bad...
either way, it will always work, supposedly.
The more you know Pascal's triangle, the quicker that shortcut is for any... and just to show you real quick, if I had a plus h to the fourth, so I'm on this level. So this is the fourth, third, second.
Yeah, I remember.
Yeah. So then this would be 1a to the fourth. Now this is kind of cool. This is the full thing I haven't shown you yet. Plus that's the coefficient, lose an a, gain an h. 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 That's what Pascal's triangle does for us. And then that f of a plus h method isn't all that evil, really.
There's more room for error.
Yeah, because you got a lot more terms running around. The other method requires you to really know factoring pretty well, right? But that to me is a good trade-off. Yeah. Let's see. What about find equation you catch up. I don't know, dude. X to the fourth plus x minus 1 at x equal to -2, sure. So see how far you can get with that, and then I'll come in a couple minutes, finish it out. Holy shit. All right, let me catch up to you, because there's going to be a point where if you don't know the process I just wrote down, synthetic division, you'll be in some trouble. You'll want to do it the other way. So, who knows synthetic division? Who's heard of synthetic division? I like it. Some of you guys are like, that sounds horrific, man. Synthetic division. Is that cyborgs dividing them? No. I'll show you. Well, so to find the slope, how would I set this up? Limit as x goes to -2. And then f of x minus f of -2. What's f of -2? 13. All over, yeah, x minus -2, so x plus 2. So I get, you don't have to do synthetic, to be honest. You could do long division if you want to. Can you factor the top of that easy? No, not really, right? Do you notice why? If that would have been a squared, maybe it would have been factorable easy, right? The middle one's got to be half the power of the first one for it to work directly. It doesn't do that kind of stuff. Man, so let me do this long division, and then I'll do synthetic division, just to show you the connection. Let's see, so if I do long division, I better put in some placeholders, because I'm missing some shit. Does this look familiar, you guys? Hopefully. Yeah. This could be like a little painful, I don't know. X times what is x to the fourth? X cubed. So then you multiply it, and then you change the signs. So you get -2x cubed, bring down no x squares. So then I get x times what is -2x cubed? Okay. Thanks for the help. And then -2x squared times 2 is minus 4x squared. And then I change the signs. That's the biggest thing people forget with long division. You always subtract, which means change the signs in that step, right? So I get 4x squared, bring down the x, just to cut to the chase, 4x squared plus 8x, change the signs, bam, bam. Bring down in -14, -7, -7x minus 14, bam, 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 0. Yeah, it goes in evenly, thank God. It has to. It really has to. That problem has to cancel. So what do I use from all this? Where's the answer to this? Yeah, that is how I can rewrite this. Now, real quick, here's synthetic division. Synthetic looks like this. It says, instead of changing the stupid sign every time, and how important is the x really? What's the most important thing on this step? Is the coefficients, what are they doing? These x's cancel, right? I mean, so here's what synthetic division does. Put a 2 down, forget about the x. Change its sign right now, right at the beginning, so I don't have to do it each time. Write down the coefficients of what I'm dealing with. Why was this a 1? Because this is a 1. So you bring that 1 down. Negative 2 times 1 is negative 2. Add 0 minus 2 is negative 2. That's where that is. Negative 2 is 4. Add 0 plus 4. Negative 2 is 4, negative 8. Add 1 minus 8. Negative 2 is 14. Add. Get the same answer. Those are the coefficients of the answer. So the synthetic just takes all the x shit that doesn't really matter out of the way. That's what the synthetic division does. So I can rewrite this as the limit as x goes to negative 2 of x cubed minus 2x squared, 4x minus 7. And that, of course, is ooh, it's like negative 31, I think. So you get negative 8 minus 8 minus 8 minus 7. I did that right. So what is that again? Slope. I love it. So that's the slope. So I know the slope is negative 31. Check. I know the point was negative 2, 13. This is really where you're trying to get. In algebra, how did I get here? They said it was parallel to this or perpendicular to this, or it went through these 2 points, so I had a way to find the slope. Now it's calculus gets that part. And then you just throw it in, and then you do the same damn thing. Y minus y1 equals mx minus x1. And then throw in what you know now. I like it. So it would be y minus 13 equals negative 31 times x plus 2. Y equals negative 31x, negative 62 plus 13 is 49. Sounds about right. So if you graph that and you graph this, you'll see that skim this right at the point. Yeah. So you get negative 62 plus 13. Yeah.
That was helpful.
Okay.
Actually, because when I'm looking at the algebra problem, like x to the 4th plus x minus 14 over x plus 2, my mind is only looking to factor. And then if I can't factor, I don't know what to do next, because I could never really identify an algebra problem and know exactly how to solve that problem.
Yeah.
So it's helpful to start thinking
But-
about it differently.
Yeah, this is what should have happened in 176. The whole point of that, when you had to find all the rational divisors, all the rational roots, and you learn synthetic division, and hopefully they made the point that is actually synthetic is a really powerful factoring tool.
Yeah.
It really is. We can see it right here. I would have never guessed that that was a piece of this, but it is, right? This says that this is this times this. Ain't no freaking way. There's no formula for that. There's no shortcut for that. Okay, I like it. But see, that's, again, it could be dredging up memories if it's been a while since you took pre-calc, or it could be the teacher never made the right focus on what it was really useful for. Unfortunately, some people teach pre-calc that never teach calc, so they don't know what to prepare their students for. So that's not your fault, but it's still supposed to be something you come in with. Yeah. All right, cool. I like it. Where do we want to go next? Oh, yeah.
Start going over the practice test.
Sure, yeah. Remember, I have the answer key to it. But what problem are you looking at?
Maybe 3 for me.
3? Okay. So 3 is the one finding all the different limits. So this is the one where you have to know the different approaches you could take based on what's in there. If I see a radical expression, I'm going to use conjugate. If I see polynomials, I'm going to try factoring or maybe even synthetic. Right? If I see fractions inside of fractions, I'm thinking LCD, get those things together. So part A is, of course, the very first thing I should do because, man, this is not a trick, and this is not evil, and any of that shit. Before you start doing any algebraic stuff, what do you check first?
If you get factor.
No, that's
Or you
algebraic
put
stuff.
the number in.
Yeah. Is there a reason to do extra shit? If this is determinant, why would I do anything else? Because that means I can determine the answer. So let's make sure it's indeterminate first. If it isn't, the answer is right there. Right? So when I plug a 5 in, what do I get? 5 cubed?
125.
Good. Minus 10 times 5 over 5 squared minus 50. That doesn't look indeterminate, right? Looks like I've got the answer already, right? I get 75 over,
Negative 12.
which is?
Negative 3.
Yeah, 3/4 makes 75 cents. I like it. Coolness. So please, dear God, you can call it a trick if you want to, but it's just, that's what you do. When you have a limit staring you in the face, make sure there's a problem in the first place. There was no problem. No problem here. Until you try to make one. So part B. Now we're going to have a problem. And you know, dorky ass Jeff is going to give you a freaking cube. You just know it. Right, so learn how to do them. What do you think 216 is related to? 125 is 5 cubed.
6.
So I bet you 216 is 6 cubed. You can check it. Right? So that's not that big of a, don't come at me and say, you gave me 216. I don't care. You're a 180 student. Shit. You should be able to just figure that out somehow. So how do I factor the top then? I know this is AAA. And I know this is 666. Yeah. So how do I factor this dude? And real quick, I kind of jumped the gun here a bit, but when you plug a negative 6 in, you will get 0 over 0 on this instance. So that's why we have stuff to do.
Do you factor out an A and then do A squared plus...
Does 216 have an A to take it out
Oh,
of?
that's right. No.
Poor little dude. Don't take an A from him if he ain't got it. We're like the tax man, just more fair. You don't take more than you got. Anybody remember cubes? Little dude, big dude. Have I said that to you yet? Little dude, big dude. This is how you set them up. So there's a little dude, and there's a big ass dude. Little dude's a little dude, so you can only fit one A in there, plus 1/6. So what goes here? The other 2 freaking A's, so that when you start to FOIL, you get your A cubed. You can see the answer start to put itself together. Well, how do you do squares? How would you do, what's x squared minus 25? Little side note. How do you factor that?
X minus 5x plus
1x, 1, 5, 1x, 1, 5. Different signs so that the middles cancel. 1A, 2 A's, 1, 6, 2 freaking 6s, so that when you start to multiply shit out, you get 3 of everything, right? Now, why do I need the middle term? Because I get extra freaking terms. So what's the middle sign? What's the sign going to be on the middle, dude? Minus, so you can cancel some of this positive shit. And what's the middle, dude? Always this times this. So in this case, 6.
Wait a minute, do that again, that last section.
So I get 6a squared and 36a, and I don't want them.
Mm-hmm.
So this has got to be minus, so its results can kill those things. And it's always whatever the shit's there times whatever the shit's there. Always. So, 1 of each, 2 of each, product in the middle. Da-da-da-da-da-da-da, don't do songs. Okay, I like it. And then on the bottom, what happens to the bottom? What comes out? 2a. And I would be left with a squared minus 36, so can we just go to the next step after that, a plus 6a minus 6? And what happens? Yeah, the thing that was making me indeterminate goes away. That idea of the problem gets killed. You gotta love that shit. And now you just plug a negative 6 in, or whatever the hell that like crap. I'm not gonna do that. I don't care about that step. Just throw a negative 6 in. Okay. Let me see. Oh, and then part C is probably the more interesting one. So we got this stuff here.
Wait a minute, is that the end? Or you keep
Well,
going?
yeah, I mean, you throw the negative 6 in. Oh.
Okay.
I mean, that I don't have to show you. Just throw it in and see what you get number-wise.
Okay.
Yeah. Part C. Let me take this away here. So everybody got all this stuff here? And again, these are all in the answer key worked out. So, you know. Now, what's kind of funny to me, well, all right, what do you know has got to happen when you throw now here's the thing about this problem that's a little bit off-putting. When you throw a 0 in, you don't get indeterminate, but it is in a way indeterminate. What do you get when you throw a 0 in? What form is the result? I'll do the top. Over 0. Now, why is that not really determinate? It looks like the answer would be...
Undefined.
Be more specific.
0.
No. Sure, does not exist, but be more specific. How can something not be do not exist as if it didn't have a ceiling or a floor? But then I could say it's positive infinity or negative infinity, right? So why can't you really tell right now? Because I don't know what sign this is. It's a weird question, isn't it? But I'm going to 0. Am I going to 0 always negative, or am I going to 0 always positive? That would change the sign of the answer, wouldn't it?
Yes.
Okay. So I need to get rid of some of this extra shit. So I need to try to factor this thing so I can get rid of some extra shit so I can really see what's going on. So here's the funny thing to me is I don't have to do a lot of work on the bottom. I really don't. When I take an H out, what do I know has to be a part of this? Yes. And we're going to check to make sure that that guess is right. But this hopefully came up in your algebra class. If not, goddamn, this teacher's got to learn some shit. But when you have these kind of problems, there's a hint in the problem, right? So what would have to go here so I get 12h squared? 4h. What would have to go here so that I get negative 6? Positive 3. Well, let's check. Minus 8 plus 9 is plus 1. So it worked. Done. If it didn't do that, I'd have to go back and do 12 times -6. Remember all that stuff? The surefire method or the AC method or the stupid big ass X that I don't know why it works for people, but oh well. Whatever works. So how can I rewrite this now? All right, what's wrong with this? Poor guy. You're like, dude, obviously I thought it was fine. Where is that? Where is it? On the bottom. Shit, yeah. That's better. All right. Right? Because these go away and go to the 1 on top. And the other thing I would highly recommend is don't multiply that stuff out. So now I can see. Can you see now? Can you see? The top is positive. The bottom, if I go to h to 0 from above, it's positive times positive. Do you guys see that? And now I've gotten rid of extra shit. I can actually see what the answer is. So what kind of infinity is the answer? Positive. It's freaking positive. Yeah, so it's positive. And you might even want to put a plus there just to really show me it was freaking positive infinity, Jeff. Just in case there's a stray mark. That makes me wonder. All right. I like it. Yeah. 7? Oh, okay. Okay. What's it say? You can pick it up and bring it over here, Jeff. There you go, buddy. This is number 7 on there. So here's what the answer to this should start off as. Given epsilon greater than 0. Let delta equal, we don't know yet. Then if x gets close to -2, I need to show that that gets close to 14. So the side work is what's going to help me get this thing rolling. But this, if you look at your quizzes I gave back, I gave you a point if you got all the right stuff, but this is really needs to be there. This is part of the proof. Somebody gives me this. So I let delta equal whatever. And then the correct thing happens. If I'm close enough to x, I'm close enough to L. Or I mean, so on the side, I used to say I don't even want to see this. I'd have people do this on another review, but now I want to see it just to make sure. If something funky happens, I can see why. Because technically, side work, you wouldn't show that if you gave this proof to somebody. You wouldn't show it. It's not really a part of the proof. It's just your side work, constructing how the proof is going to run. So how do I start this one?
Subtract 14 on both sides.
Well, I got nothing to work with here. Yeah, so I want f of x minus the limit. There's got to be less than epsilon. That's where I want to end up here. And now you just do a bunch of algebra to it. Here's the key thing, though. What can I do with this?
Factor the 3 out. Or take the
Everybody's
negative
saying
outside.
3. Yeah, but you can't take a negative outside. You can't do that shit.
No.
Nope. Because then the absolute value of -8 would be -8.
Oh, right.
That doesn't make sense. Isn't this the absolute value of -3 times x plus 2? Right? And what's the absolute value of -3? 3. So really, the negatives just disappear. Because the absolute value of negative something is the absolute value of that thing. Because the absolute value would strip the negative off anyway.
Just why is it absolute value? Why does it turn into that? Is it because epsilon can never be
All right,
negative
all right.
number?
Nothing turns into anything. Be really careful, because when you said to subtract 14 from both sides, I'm not working with this directly like an equation. That's not really what this is. The idea is the function has to be getting close, and absolute value, of course, is distance. The function has to be getting close to 14. How close? This close. So absolute value is distance. So the distance between my function values and 14 needs to be getting really, really small, arbitrarily small, as my x's get really close to that -2. That's the whole idea. I love it. So we're applying an idea. We're not really working with this. We're applying an idea. And then, of course, I can do this, and then what does this tell me? What's that tell me?
So I'm sorry, is negative 14 x? Like, is that one way to think of it?
No. What is negative? No. What is 14? It's not no negative 14 up there. It's the function minus what letter goes here in general?
A or
No.
x?
No. What is 14? It is the
Limit?
limit. 14 is the limit.
Oh, okay.
Yeah.
Oh, so that's on the right as well.
Yes. I love it. So the difference between the y stuff has to be getting arbitrarily small if the difference between the x stuff is getting small. That really is the idea of a limit. This just like makes it really formal. So what does that tell me, what we just did? What does this sign work tell me?
The epsilon is 1/3 the distance from L in either direction? No?
Nope. Nope. So, all right. So we want to show
What's
if
the limit?
x minus a is less than f of x minus L is less than epsilon. What's this? What's the other freaky ass Greek letter involved in this proof?
Delta.
Delta.
Oh,